Hello everyone. In this video, I will be talking about elasticity, plasticity, stress and strain. So mechanical properties of solids. First introduction. A solid has definite shape and size. In order to change or deform the shape or size of a body, a force is required. The property of a body by virtue of which it tends to regain its original size and shape when the applied force is removed is known as elasticity, and the deformation caused is known as elastic deformation. If the body remains deformed even after the applied force is removed, then the body is said to be plastic, and this property is called plasticity. For example, if we apply force to mud, the shape of the mud is deformed. It does not return to its original size. Now, elastic behavior of solids. Here, what causes the elastic behavior of solids is explained. So, in a solid, each atom is surrounded by neighboring atoms bounded together by interatomic forces. The figure shows a orientation of atoms in a solid. When a solid is deformed, the atoms or molecules are displaced from their equilibrium positions, causing a change in the interatomic distances. So when the deforming force is removed, the interatomic forces tend to drive them back to their original position. Thus the body regains its original shape and size. So it is because of the interatomic forces why solids are able to regain their size or shape or exhibit this elastic behavior. Now stress. When a body is subjected to a deforming force, a restoring force is developed in the body. This restoring force is equal in magnitude but opposite in direction to the applied force. The restoring force per unit area is known as stress. If F is the force applied and A is the area of cross section of the body, then magnitude of stress is given by force divided by area. The SI unit of stress is Newton meter raised to -2 or Pascal, and its dimensional formula is ml minus 1 T raised to -2. Now we shall see different types of stress. A cylinder is stressed by two equal forces applied normal to its cross-sectional area. The restoring force per unit area in this case is called the tensile stress. The same cylinder, when it is compressed under the action of applied force, the restoring force per unit area is known as compressive stress. The tensile stress and compressive stress can also be termed as longitudinal stress. If two equal and opposite deforming forces are applied parallel to the cross-sectional area of the cylinder, there is relative displacement between the opposite faces of the cylinder. The restoring force per unit area developed due to the applied tangential force is known as tangential or shearing stress. Here, as you can see, the cylinder is displaced by an angle. Now, next is hydraulic stress. A solid sphere placed in the fluid under high pressure is compressed uniformly on all sides. The force applied by the fluid acts in perpendicular direction at each point of the surface and the body is said to be under hydraulic compression. This leads to decrease in its volume without any change of its geometrical shape. The body develops internal restoring forces. The restoring forces thus developed per unit area is called hydraulic stress. As you can see in the figure, the volume of the sphere is decreased by amount delta V. Now we shall see about strain. Strain is the ratio of change in dimension to the original dimension. It has no units or dimensional formula. Similar to stress, there is also longitudinal strain. It is given by the change in length, delta L divided by the original length. And then there is shearing strain, which is given by the total displacement due to the force delta x divided by L. That's equal to tan theta, where theta is the angle by which the cylinder is sheared. And then there is the volume strain. And volume strain is given by delta V by V, where delta V is the change in volume due to hydraulic deformation. Now we shall see Hooke's law. It gives a relationship between stress and strain. It states that within the limit of elasticity, the stress induced in the solid due to some external force is always in proportion with the strain. In other words, the force causing stress in a solid is directly proportional to the solid's deformation. Now we shall see the stress-strain curve. For drawing a stress-strain curve, we shall first take a cylinder, a test cylinder, and a longitudinal force is applied to it. And the readings of stress as well as strain are taken and are then plotted as shown in the figure. At first, up to point A, the stress-strain curve shows elastic behavior. That is, in this area, the material obeys Hooke's law. Then from point A to B, that is, point B is known as the elastic limit or yield point. That is if there is a point where maximum yield of stress is possible. After this, for a small change in stress, a far greater amount of strain is produced. The point C is the point after which the material won't exhibit any elastic behavior, and this known as permanent set. Then from C to D, it shows plastic behavior. That is, for a small change in stress, a far greater change in strain is produced. At point D, it is the ultimate tensile strength or the maximum stress that can be given to the material. After point D, the strain produced will be far greater. The point E is the fracture point. The fracture point is the point at which the material breaks apart. If the distance between D and E is large, then the material is called ductile. So this is the end of this video. In this video, I have explained elasticity, plasticity, stress, and strain. If you have got any doubt in any of the topics discussed in this video, please comment in the section below this video. Thank you.